Hi everybody, it's Ms. Dupree. In today's lesson, we're going to explore states of matter. Many of you have already identified solids, liquids, and gases as types of matter, and you're absolutely right. But what makes a solid, or a liquid, or a gas? In this lesson, we'll take a look at some of the properties of solids, liquids, and gases, and then we'll take a look at what's happening to the molecules themselves. So let's start with the properties of solids. There are 4 properties. The first one is shape. Solids have a fixed shape, meaning that solids don't change their shape depending on the container that they're in. An apple sitting in a bowl is still apple-shaped. It doesn't become bowl-shaped just because it's in a bowl. If you put it into a cup, it's still apple-shaped. It does not become cup-shaped. The only way that you can change the shape of the apple is to smash it or cut it. The second property is volume, or size. Solids have a fixed volume. This means they keep their size. This apple is the same size whether it's in the bowl, or in the cup, or in any other container. Because solids have a fixed volume, it means they cannot be squashed or made smaller. You can't put your hands around this apple and squeeze it and make it shrink to a smaller size. The final property of solids is that they do not flow. The word flow means that when a substance is poured, it makes a steady and continuous stream of particles, like this. Think of water being poured into a cup, how it seems to make a line of water while it's pouring. Solids don't do this. If I pour this apple from the cup into the bowl, the entire apple is just going to kind of clunk down in one movement. Solids don't flow. Now let's take a look at the properties of liquids. The first property is shape. Now liquids will change their shape to match the container that they're in. So the liquid in this round container here is a round shaped piece of liquid, while the liquid in this flask takes on the more triangular shape of the flask. But even though the shape changes, the volume of liquids stays the same. If I pour 400 milliliters of liquid from the flask on the left into the graduated cylinder on the right, the shape is going to change from the flask shape to the graduated cylinder shape, but the volume stays the same. I still have 400 milliliters of liquid. So you also cannot squash liquids into a smaller size. If I have 400 milliliters of water in this flask, I can't squeeze it so that I only have 300 milliliters of water. That's impossible. But what liquids can do is flow. When you pour a liquid from one container into another, it pours in this steady, continuous stream. See the line the water's making? This is what a substance looks like when it's flowing. So liquids are able to flow. Now let's take a look at the property of gases. The shape of gases can change to take the shape of their container. Look at the balloon inside this jar. Right now we have just a balloon-shaped piece of gas inside the balloon. But if I pop the balloon, the gas is going to spread out and it's going to take on the shape of the jar. So now I have more like a jar-shaped section of gas. Now, one thing that makes gases different from liquids is that liquids can take the shape of their container, but only like the bottom where the liquid flows. Gases can flow all over their container. And so what that means is that the size of gas, the volume of gases can change. Instead of a small balloon-shaped or balloon-sized piece of gas, because it has spread out into the jar, now we have a larger volume of gas. And this also means that gas can be squashed or made smaller. If I had the right tools, I could take all of the gas particles and squeeze them back into the balloon. So now my piece of gas would be smaller again. And finally, gases can flow. If you hold a balloon and let the air out, you can feel the air coming out in a continuous stream of gas. Gases are able to flow. So those are the properties of solids, liquids, and gases that we can observe. But what makes them like this? Well, it's all about what's happening with the molecules. It's important to understand that no matter whether a substance is a solid, a liquid, or a gas, that doesn't change the molecules themselves. It doesn't change the structure of the molecules. A molecule of water, or H2O, will always be a molecule of H2O, whether it's in ice or liquid or steam forms. What changes is how the molecules are arranged and the amount of energy that they have. So let's take a look. We'll start with solids. The molecules in solids are very low energy. That means that the molecules have just enough energy to vibrate, like you see going on here. They're just kind of vibrating, just moving just the littlest bit. But they don't have enough energy to move around. The molecules in solids, because of their low energy, they're packed really tightly together. And that means that they don't have room to move past each other. It's kind of stuck there. They can't move past each other, so they stay in fixed positions. They're vibrating, but they're not moving around. Now, the molecules in liquids have more energy. We'll say that they're medium energy. And because they have more energy, they're still slow, but you'll see that they're moving around a little bit faster than the solid molecules, and they're moving around more. And this causes them to bump into each other and push each other, which causes them to spread out a little bit. So the molecules in liquids are more spread out. And since they're moving more, they have enough room to start moving and sliding around past each other. They're not fixed in position like solids, but they're still pretty close to each other with just enough room to slide around. So that's how the molecules in liquids are different than the molecules in solids. Now, the molecules in gases have the most energy. These are going to be our very high energy molecules. And because they have lots of energy, they move around really quickly, and they're bumping into each other and they're pushing around. And because they're going so fast, the molecules in gases, they get spread very far apart, and they're flying around in all directions. So if you pop a balloon full of air, those gas molecules are going to go flying all around until they're spread all over the room. Okay, that's it for this lesson. Make sure you understand the properties of solids, liquids, and gases, and that you can explain what's happening at the molecular level as well. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.